In this lesson, we're going to talk about some basics for expressions. We're going to talk about what an expression is and then how to go back and forth between words and symbols. All right, so first, what is an expression? So there's some different parts. This is an example of an expression. Okay, the coefficient is the number in front of the variable. So the 2 is in front of the variable. The prefix co means with. Efficient means number. So this is the number with the unknown number. It goes with it. They go together. It's multiplication 2 times x, but we don't always write that times sign. This x, this is the variable. And it's the letter or symbol replacing a number that we don't know yet. And then the number by itself, standing alone, is called the constant. 3 can never change its value. Its value remains constant, and that's where its name comes from. Give my screen a second to refocus here. Sometimes it's a little blurry. There we go. Welcome back. All right, terms. Terms in expression are separated by the plus or minus signs, and I think of them as the big chunks of the expression. So if I look at this expression, this 4x and this minus 5, this minus sign separates it, and we tend to group it with whatever comes after. So there are 2 terms. It's called a binomial, and we'll come back to that vocabulary later. But just so you know, binomial has 2 terms. 4x is one, negative 5 is another. A trinomial, like a tricycle, has 3 wheels. A trinomial has 3 terms. The 6x is 1, the minus 7y is 1, and the plus 8 is 1. So again, these are the big chunks. These are the independent separate pieces, coefficient, variable, constant. The terms are the big chunks separated by a plus or minus. All right, examples. Identify the number of terms, the constants, the variables, and the coefficients. So my first one, there are no pluses and minus signs, so there is 1 term. It's just 9x. Okay, constants. There are no numbers by themselves. There's nothing added like a minus 5 or a plus 8 or a plus 3. So there are no constants. The variable, this is that letter or symbol. The variable is the x. And the coefficient is the number in front of the variable, so that's the 9. All right, example 2. Here's a minus sign. It's splitting here. So I have 2 terms. Again, that's called a binomial, but we'll come back to that vocabulary later. Bi, like a bicycle, 2 wheels. Binomial, 2 terms. Okay? And my terms are 10x and negative 1. Okay, my constant is any number that stands by itself. Negative 1 is standing by itself, so that's my constant. Notice I grab the minus sign with it. Okay, always grab that sign ahead of time. All right, my variable is again x, and my coefficient, number in front of the variable, 10. All right, last example. I'm separating it all the pluses and minuses. So I have 3 terms. Trinomial. They are 2x, a negative y, and a 4. Constant, number by itself. That's a 4. I don't have to write the plus sign, that's implied. I do have to write a minus sign if there's a negative. Okay? My variable, or variables, these are my letters or symbols. It's going to be x and y. And my coefficient is actually 2. I have 2 here. And when I have just a minus, there's really a hidden 1 in here. It's a little tricky, but when you don't see a number, it's a hidden 1. Kind of confusing, but you've just got to remember 1 times y is y. So it's an implied 1. Just kind of like this is an implied positive, there's an implied 1, and it's negative because of the minus sign out in front. So those are the parts of an expression. Next we're going to talk about how to translate expressions. So how to translate them from words into symbols or symbols into words. There's some keywords here for you to look for: addition, subtraction, multiplication, and division. I'm not going to read them all to you. I do want to give you a little heads up about a couple. When you see the words more than or less than, the variable expression is written backwards from the verbal expression. Think about what would you do if somebody asks, what is 2 less than 5? Your answer would be 5 minus 2, or 3. Notice you put the 5 first, and then the 2 second. So really here it says 2 first and 5 second. Here you have 5 first and 2 second. So it's a little bit backwards. Those tend to trip up students. Okay, so just kind of be aware of that. Put that in your brain. And the word of, this only usually means multiplication, but not always. Be sure to read the question carefully. And I am going to show you a couple, at least one example where of does not mean multiplication. So just kind of be aware of that word. All right, write the following verbal expressions as variable expressions. So let's start with this one. 1 divided by 2. Pretty easy. We have 1 divided by 2. In algebra, okay, we're not going to use this symbol very often. We're going to always write this as 1 over 2. So we're going to use that fraction notation. This isn't wrong, but it's not proper math grammar for algebra students. So we're going to write 1 divided by 2 as a fraction. 5 more than 6. Remember, more than is one of those ones where we do backwards. So we're going to have 6 plus 5. That than is a tricky word. You've just got to be on the lookout for it. All right, 3 less than 4. There's that than word again. So we're going to have 4 minus 1. Less than is subtraction, more than is addition. The difference of 7 and 8. Difference is a subtraction word. So we're going to have 7 minus 8. 5 times 6. Times is a multiplication word. So that's 5 times 6. But in algebra, we are going to write that without any symbols. So we're going to use that parentheses notation. Again, for algebra students, this is proper math grammar. All right, the product of 9 and 10. So that's going to be 9 times 10. Product is a times word. Second, underline some of those keywords there. Less than, more than, and divided by. Okay, this list is not all inclusive. There are more words than what's listed there, but those are the ones you see most often. Last page for today. Translating expressions, just a little bit more. These are going to get a little bit more complicated. All right. And center. Perfect. Words that mean a variable. You might see a number, what, or unknown. You might also see the letter itself written out. Words meaning grouping symbols, the quantity of, or the sum of, or the difference of. Okay. When writing multiplication with a variable, do not write the symbols. Always write the number or the coefficient first. When writing division, always use the fraction bar. First term of the numerator and the second, or the first term is the numerator and the second term is the denominator. Examples. Write the following verbal expression as variable expression. All right, here we go. The sum of 7 and a number. So a number, you could pick any variable you want. Remember, that means variable. I can use an x or a y. Okay. Sum means plus. So I'm adding 7 and x together, so I get 7 plus x. Notice how I annotate a little bit. I tend to write above directly what operations I'm doing and what things I need to fill in. All right, 2/3, that's 2/3 of, typically means times. Okay, and I'm going to use a dot here because I don't want to confuse times with x, a variable, or a number. So this is 2/3 times x, but notice our tip said when writing multiplication, do not write the symbols. So we're going to write this as 2/3 x. The product of a number and 8, product means times, a number is a variable, and 8 is 8. So product is times, again use the dot, a number is x, and 8 is 8. So we're going to write the coefficient first, 8x. Even though a number is listed first, even though the variable is listed first, we want to make sure we always put the coefficient before the variable. 15, decreased by, subtraction, twice a number. Twice means times 2. So 15 decreased by 2 times a number. Again, you don't have to use X. You can use A, B, C, Q, whatever. I would not use O. Looks like 0. I would not use S. It looks like 5. Those are 2 variables you probably want to stay away from. The quotient of 9 and an unknown. Quotient is a division word. So 9 and an unknown, 9 over X. Again, we're using the fraction notation for division. Always use the fraction bar. All right, 10 less than. Remember than, that's a tricky word. The difference of 7 and a number. That difference of is parentheses, so we know we're going to have to put in parentheses 7 and a number. So we have parentheses around difference is subtraction, 7 and a number, and 10 less than that. So 10 less than the difference of 7 and a number. Okay. 10 less than a number. That one's easier. We have a number, less than is subtraction, 10 minus X. 9 times the quantity of, so we know we're going to need parentheses, quantity of, 2 and an unknown. And in this case is addition, so we have 2 and an unknown, times is multiplication, we're multiplying by 9, and again that number goes out in front just like before. Okay. Last example, Mr. Martinez orders 250 keychains printed with the team's logo and 500 pencils printed with their website address. Write an algebraic expression that represents the cost of the order. Okay, so I'm going to use C for the cost of the keychains. And actually, I'm going to change that to a K so we don't get confused about cost and keychains and what it stands for. So K is the cost of the keychain, and P is the cost of the pencils. Okay, so I have 250 keychains. It's going to be times the cost per keychain, so 250K. And we want to know the cost of the order. That would be the total. So that's going to be in addition to the cost of the pencils, 500 pencils times the cost per pencil. We should say cost of 1 pencil and cost of 1 keychain. We've got a little less confusing there. So that's how you translate verbal expressions.